The animal we are about to follow does not announce itself. It does not break the surface with spectacle or remain long enough to be admired. Most of its life unfolds far from sunlight, beyond any coastline, in water so deep that pressure replaces gravity as the dominant force. And yet this animal holds a distinction unlike any other that has ever lived on Earth. It is the largest predator in the planet's history. Not the largest animal, that title belongs elsewhere, but the largest creature to ever survive by hunting other animals. Larger than any land predator, larger than any known carnivorous dinosaur, larger than any shark, past or present. The sperm whale carries this distinction quietly, almost invisibly, moving through the ocean without urgency, without display, without any apparent awareness of how unusual it truly is. A fully grown male sperm whale can reach lengths of more than 20 meters and weigh over 50 tons. To picture that mass on land is to imagine collapse, muscles straining under their own weight, bones pressed downward by gravity. But in the ocean, size behaves differently. Water carries weight, it distributes force, it allows mass to exist without dominance, without aggression, without the need for speed. In this environment, being large does not mean being violent, it means being stable. The sperm whale is not built like a sprinter or a pursuer. Its body does not narrow into speed. It does not taper into elegance. Instead, it is thick, dense, almost rectangular in profile, especially at the front, where its enormous head accounts for nearly a third of its total length. That head alone can weigh more than an adult elephant. Inside it is a structure so unusual that it puzzled scientists for centuries and gave the animal its name. But the purpose of that structure is not domination, it is adaptation. Predators on land tend to advertise themselves through motion. They chase, they stalk, they strike. The sperm whale does none of these things in a way that would look familiar to us. It does not hunt by sight in open space. It does not rely on sudden speed. It does not engage in pursuit across distances. Its version of predation is patient, methodical, and deeply bound to an environment where nothing happens quickly. To understand why the sperm whale is classified as a predator at all, it helps to let go of terrestrial ideas about hunting. In the deep ocean, prey does not flee across plains or forests. It drifts, it pulses, it appears and disappears in darkness. The sperm whale does not overpower this world, it belongs to it. Most of its prey consists of squid, animals that themselves are rarely seen alive by humans. Giant squid, colossal squid, species that spend their entire lives far below the surface, suspended in water that never warms and never brightens. The sperm whale descends into this realm not as a conqueror, but as a specialist. It goes where almost nothing else can follow. This is what separates it from other large animals. Many whales are large, but few are hunters in this sense. Baleen whales feed by filtering enormous volumes of water, gathering tiny organisms in vast numbers. Their size supports this strategy. The sperm whale's size supports something else entirely. It allows long descents into pressure. It allows oxygen to be stored in muscle and blood. It allows the body to slow down and endure. On land, predators are defined by what they can overpower. In the ocean, predators are defined by what they can reach. A sperm whale can dive more than a kilometre below the surface, sometimes remaining underwater for over an hour. At those depths, the weight of the water above is immense. Light does not exist. Temperature remains near freezing. There are no visual landmarks, no sense of direction that humans would recognize. And yet, the sperm whale moves through this space with consistency and purpose, locating prey using sound instead of sight. navigating a world that exists entirely beyond human intuition. This is why size in the ocean does not function as intimidation. The prey of a sperm whale is not aware of its mass. A squid does not see a vast shape approaching from the darkness. It experiences pressure changes, sound, vibrations, then contact. There is no chase in the conventional sense, no drama, no visible struggle. The encounter is brief, efficient, and silent. When people hear the phrase largest predator, the imagination tends to reach for violence, teeth, power, dominance. The sperm whale has teeth, large, conical teeth, but they're not its primary tool. They are rarely used to tear. Instead, prey is often swallowed whole. The teeth may help grasp, but the hunt itself is guided by a sensory system far more important than bite force. The ocean does not reward aggression, it rewards efficiency. In water, moving fast costs energy, chasing costs oxygen, struggling costs time. The sperm whale's success comes from minimizing all three. Its mass allows it to glide, its density allows it to descend without effort, its physiology allows it to remain calm in environments that would overwhelm most animals within seconds. Even its surface behavior reflects this economy. When sperm whales breathe, they do not linger. They surface, exhale in a low, angled plume, inhale again, and repeat this rhythm slowly. Then, without ceremony, the tail rises, the massive flukes lift briefly into the air, and the animal slips downward, disappearing completely. There is no splash, no display. The ocean closes behind it as if nothing passed through. This lack of spectacle is one reason sperm whales remain strangely abstract to many people. They are known, but not familiar. Famous, but rarely observed. Their lives unfold on timescales and at depths that do not intersect often with ours. And yet, their presence has shaped ocean ecosystems for millions of years. A predator of this size requires a vast range. Individual, sperm whales can travel across entire ocean basins, moving between feeding grounds and breeding areas that may be separated by thousands of kilometers. But even in motion, they are not hurried. They move with a consistency that reflects long evolutionary refinement, not urgency. Aggression implies competition. The sperm whale faces very little of it. As an adult, it has few natural threats, not because it is violent, but because nothing else occupies the same ecological space. There is simply no other animal that hunts the same prey, at the same depths, with the same endurance. This isolation removes the need for confrontation. Even interactions between sperm whales are subdued. They do not establish dominance through fighting. They do not defend territories. They exist alongside one another through spacing, sound, and memory rather than force. This is perhaps the most counterintuitive aspect of being the largest predator in Earth's history. The sperm whale does not rule its environment, it fits into it. On land, large predators often become symbols of control. Lions, bears, big cats. They shape landscapes through fear. In the ocean, fear dissipates with distance and depth. The sperm whale does not create visible boundaries. It does not alter behavior through intimidation. Its influence is quiet and indirect, expressed through feeding, movement, and the cycling of nutrients through the water column. Even its sheer size does not dominate space in the way we expect. Water absorbs presence. A 50-ton animal can pass beneath a ship unnoticed. Entire families of sperm whales can move through deep water without ever breaking the surface at the same time. To be large in the ocean is not to be seen, it is to be supported. And this difference explains why the sperm whale could grow to such proportions at all. On land, size is limited by gravity and food availability concentrated in small areas. In the ocean, food is dispersed across depth, not distance. Energy is found vertically rather than horizontally. A large body allows access to that vertical world. The sperm whale's size is not excess, it is function. It allows the animal to descend repeatedly into darkness, to withstand pressure without damage, to slow its heart to a few beats per minute, to remain still when stillness is required, and to return to the surface without urgency. It allows the animal to live a life measured not in moments of action, but in long intervals of movement and rest. This is why the sperm whale's story does not begin with drama. It begins with scale and patience, with an understanding that being the largest predator does not mean being the loudest, the fastest, or the most visible. It means being precisely suited as a world that few others can enter. And it is from this foundation, size without aggression, power without display, dominance without conflict, that the rest of the sperm whale's life unfolds, not at the surface but far below it, where time stretches, light vanishes, and sound becomes the primary connection between an animal and its world. If size gives the sperm whale access to the deep, time is what explains why such an animal exists at all, because nothing about its body makes sense when viewed on a human scale. Its proportions, its behaviour, even the way it uses sound instead of sight, are not solutions to modern oceans but responses to ancient ones. Long before humans appeared, before coastlines took their current shape, before the oceans carried the chemistry they do today, the ancestors of sperm whales were already experimenting with a life that blurred the boundary between land and sea. Their story does not begin in deep water, it begins in shallow coastal environments, in a world that looked very different from the one we know. Roughly 50 million years ago, during a period when Earth was warmer and sea levels were higher, early whales were not fully aquatic giants, but semi-aquatic mammals that still carried the marks of their land-based origins. They had legs. They walked awkwardly along the edges of ancient seas, slipping into the water to feed and returning to land to rest. These early forms were not large. They were not specialized. They were experiments, moving between worlds, testing what the ocean could offer. Over millions of years, those experiments accumulated. Legs shortened, feet broadened, bodies elongated. The spine began to move differently, flexing up and down instead of side to side. Nostrils migrated slowly backward along the skull, inching toward what would eventually become the blowhole. Each change was small, almost trivial on its own, but time allows small changes to stack into something unrecognizable. As generations passed, some lineages committed fully to the water. They no longer returned to land. Their bodies grew heavier, not with muscle, but with adaptations that allowed control in a buoyant world. Bones became denser in some areas, lighter in others. Hearing changed. Vision became less central. Sound began to take on a new importance, especially as these animals moved farther from the well-lit surface and into deeper, darker zones. By the time the lineage that would lead to modern sperm whales began to separate from other whales, the ocean itself had changed. Continents had shifted. Currents had reorganized. Entire ecosystems had risen and vanished. The deep ocean, once relatively uniform, became more structured, layered by temperature, chemistry, and pressure. This created new niches, places where food was abundant but difficult to reach. Squid, in particular, diversified and moved into deeper waters, evolving alongside the growing complexity of the ocean interior. For a predator capable of following them, This represented an opportunity measured not in years but in geological eras. The ancestors of sperm whales did not become deep divers suddenly. They were drawn downward gradually, generation after generation, as individuals that could tolerate slightly more pressure, slightly longer breath holds, and slightly darker environments gained access to food others could not reach. Over time, this selective pressure reshaped everything. Lungs grew larger relative to body size. Blood chemistry changed to store more oxygen. Muscles became reservoirs, capable of holding oxygen directly rather than relying solely on circulation. The heart learned to slow itself dramatically, conserving energy and oxygen during long descents. None of these traits appear overnight. They require patience on a scale that humans rarely consider. To say that sperm whales have existed longer than humans is technically true, but misleading in its simplicity. Humans have existed in our current form for roughly 300,000 years. The lineage leading to sperm whales began its aquatic transition tens of millions of years ago. Entire human civilizations rise and fall in the time it takes for a minor anatomical change to spread through a whale population. When sperm whales were already established as deep diving specialists, early human ancestors were still adapting to life on open savannas, unaware that an entirely different world existed beneath the ocean surface. Ancient oceans were not just older versions of today's seas. They were warmer in some periods, cooler in others, with different circulation patterns and different distributions of life. In some eras, oxygen levels were lower, forcing marine animals to become more efficient. In others, nutrient flows favoured massive blooms of plankton, supporting larger and more complex food webs. The sperm whale's design reflects survival through all of this variation. It is not optimized for a single moment in time. It is robust across change. Its reliance on sound rather than light, for example, is not a response to modern murky waters, but an adaptation to a world where light has always been unreliable at depth. Sound travels efficiently through water regardless of era, making it a stable sensory foundation across millions of years. The same is true of its size. Becoming large was not about overpowering prey, but about stability and endurance. In a fluctuating ocean, where food sources shift vertically and horizontally, a large body acts as a buffer. It stores energy. It smooths out scarcity. It allows an animal to travel farther between meals, to dive deeper without panic, to wait. This waiting is central to understanding the sperm whale. Its life unfolds slowly because it evolved in a world where speed was not rewarded. Ancient oceans did not favour animals that rushed. They favoured those that endured. Reproduction itself reflects this pace. Sperm whales mature slowly, reproduce infrequently, and invest heavily in each offspring. This strategy only works when environments remain relatively stable over long periods, which the deep ocean largely does. While surface conditions fluctuate with climate shifts, storms, and seasonal changes, the deep remains cold, dark, and consistent. That consistency is what allowed the sperm whale's ancestors to commit fully to a deep water lifestyle without being punished by sudden environmental swings. Looking at the sperm whale today is like seeing a living archive. Its body carries solutions to problems that no longer exist in the same form, alongside solutions to challenges that remain unchanged. The massive head, for example, makes little sense if judged by surface behaviour alone. But when viewed as part of a long evolutionary conversation with pressure, sound propagation, and buoyancy control, it becomes inevitable. The same can be said for the whale's teeth, which seem excessive for swallowing prey whole, but persist because evolution removes only what is harmful, not what is merely unnecessary. Time is generous in this way. It tolerates redundancy. It favours reliability over elegance. This long perspective removes urgency from the sperm whale story. There is no rush toward an endpoint, no sense of progression towards something better. The animal we see today is not a final version. It is simply the current expression of a lineage that has been adjusting for tens of millions of years and will continue to adjust long after humans are gone. Modern biases tend to frame animals in terms of function and efficiency, as if each trait must justify itself immediately. The sperm whale resists this framing. Its traits only make sense when viewed as layers, accumulated slowly, responding to pressures that no longer exist in the same way. This is why studying sperm whales often feels less like biology and more like geology. Their lives operate on timescales that overlap with shifting continents and changing oceans. Their behaviours echo conditions that predate ice ages and mass extinctions. When a sperm whale descends into the deep today, it is not just performing a biological act. It is reenacting a pattern refined across epochs, moving through layers of water that have existed longer than any human story. This perspective changes how the animal is perceived. It is no longer simply a large predator moving through modern seas. It is a continuation, a thread that connects ancient coastal mammals to the deepest reaches of the present-day ocean. Its calm, unhurried movements reflect a lineage that has never needed to hurry, because time itself has always been its most abundant resource. And it is within this deep, patient framework that the more immediate details of the sperm whale's body begin to make sense, not as isolated features, but as the physical record of millions of years spent adapting to a world that rarely changes quickly and never explains itself. Seen through the lens of deep time, the sperm whale's body stops being strange and starts becoming inevitable. Because every curve, every proportion, every seeming excess is tied directly to the demands of a life spent moving vertically through water rather than horizontally across a surface. At first glance, the sperm whale does not resemble what many people imagine when they think of a whale. It lacks the smooth symmetry of baleen whales. It does not taper elegantly from head to tail. Instead, it appears almost blunt, front-heavy, with a massive squared-off head that dominates the body and a narrower rear that seems almost understated by comparison. This imbalance is not aesthetic accident. It is the physical record of an animal designed around depth, pressure, and endurance rather than speed or maneuverability. The sperm whale's body is essentially a long, flexible cylinder built to sink and rise efficiently. Its torso is thick and dense, packed with muscle and blubber that serve multiple purposes at once. Blubber is often misunderstood as simple insulation, but in the sperm whale it functions as thermal protection, energy storage, and structural support. At depth, where temperatures hover just above freezing, maintaining internal warmth is essential, but equally important is maintaining buoyancy. Blubber has a density slightly lower than seawater, helping counterbalance the whale's heavy bones and muscles, allowing it to achieve a near-neutral buoyancy that makes long descents less costly. Beneath the blubber lies a powerful layer of muscle, not arranged for sudden bursts of speed, but for sustained economical movement. These muscles drive the up and down motion of the tail flukes, the primary source of propulsion. Unlike fish, which move side to side, whales move vertically, flexing the spine and tail in a slow, rhythmic pattern. This motion is incredibly efficient over long distances and long durations. It allows the sperm whale to cruise calmly at depth, expending as little energy as possible while searching for prey. The skeleton that supports this motion is equally specialized. Compared to land mammals, sperm whales have lighter, less mineralized bones in many parts of the body. This reduces overall weight and minimizes the risk of skeletal damage under pressure. At the same time, certain bones, particularly in the skull, are massively reinforced to support structures unique to this species. The skull itself is one of the most remarkable anatomical features in the animal kingdom. It is asymmetrical, unlike most mammalian skulls, and houses not only the brain but also the complex system responsible for producing and focusing sound. This asymmetry is not a flaw, it is a solution. Sound production and echolocation require precise internal geometry, and over millions of years the sperm whale's skull has shifted and reshaped itself to optimize this function. The head's sheer size is often mistaken as a sign of intelligence or aggression, but its true purpose is mechanical and acoustic. A significant portion of the head is filled with oil and waxy substances contained within the spermaceti organ and surrounding structures. These materials change density with temperature and pressure, contributing to buoyancy control during dives, while also playing a role in sound generation and focusing. The brain, large as it is, occupies only a fraction of the head's volume. This challenges human assumptions about head size equating to mental dominance. In the sperm whale, head size reflects environmental demands rather than cognitive display. Moving along the body, the skin itself deserves attention. Sperm whale skin is thick, elastic, and capable of withstanding repeated compression and expansion as the animal dives and resurfaces. At extreme depths, pressure can compress air-filled spaces dramatically, but the sperm whale's body contains very few such spaces. The lungs collapse safely during deep dives, reducing nitrogen absorption and protecting against decompression sickness. This collapse is not harmful. It is expected and accommodated by the surrounding tissues. Few land animals could survive such repeated internal changes, but the sperm whale's anatomy treats them as routine. The absence of a dorsal fin is another feature that often goes unnoticed. Instead of a tall fin, sperm whales have a series of low ridges along their backs. This reduces drag and prevents damage during deep dives or when surfacing beneath ice or debris. Every protrusion on the body has been minimized unless it serves a clear purpose. Even the flippers are relatively small compared to the animal's size. They are used for subtle steering and balance rather than propulsion, reflecting a design that favors straight, steady movement through open water. Density plays a crucial role in how the sperm whale interacts with its environment. At the surface, the whale is slightly buoyant, making breathing and resting easier. As it descends, changes in lung volume, blood distribution, and tissue compression alter this balance, allowing the whale to sink with minimal effort. This dynamic buoyancy is not controlled consciously, but emerges from the interaction between anatomy and physics. The whale's body is essentially tuned to the ocean, responding automatically to depth in ways that reduce energy expenditure. This tuning extends to the distribution of oxygen within the body. Unlike humans, who rely heavily on lung oxygen, sperm whales store much of their oxygen in their blood and muscles. High concentrations of myoglobin in muscle tissue allow oxygen to be held and released slowly during dives. This reduces the need for rapid breathing and supports the long periods of stillness that characterize deep hunting. The heart itself adapts by slowing dramatically during dives, sometimes beating only a few times per minute. Blood flow is prioritized to essential organs like the brain and heart, while less critical tissues temporarily receive less. This redistribution is possible only because the body has evolved to tolerate it. Many tissues can function anaerobically for short periods, preventing damage during extended dives. Compared to other whales, sperm whales stand apart not just in size but in specialization. baleen whales are built for filtering vast amounts of water near the surface or in mid-depths, with streamlined bodies optimized for long horizontal migrations. Toothed whales like dolphins and orcas are built for speed, agility, and complex social hunting near the surface. The sperm whale occupies a different niche entirely. Its body is not optimized for chasing fast-moving prey or maneuvering through crowded environments. It is optimized for solitude, darkness, and depth. This specialization explains many of its apparent oddities. The small eyes, for example, are not signs of poor vision but reflections of an environment where vision is rarely useful. At depths where sunlight never reaches, investing heavily in eyesight offers little return. Instead, sensory investment has shifted toward hearing and sound production, systems housed largely within the massive head. The result is an animal whose external form may appear awkward by surface standards but is internally coherent when viewed in context. Endurance is perhaps the defining theme of sperm whale anatomy. Everything about the body supports long cycles of descent, hunting, ascent, breathing, and rest. There are no shortcuts, no rapid transitions. The whale's movements are deliberate because its environment rewards deliberation. Fast movements create turbulence and noise that can interfere with echolocation. Sudden exertion consumes oxygen that may be needed later. Stillness, by contrast, conserves resources and sharpens perception. This anatomical story prevents confusion later when diving behavior becomes more extreme. The sperm whale does not dive deeply because it is daring or reckless. It dives deeply because its body is built to make such dives routine. Pressure that would crush other animals is absorbed and distributed. Cold that would sap energy is insulated against. Darkness that would disorient becomes irrelevant in a world defined by sound. The whale's anatomy does not fight the ocean. It yields to it, accommodates it, and in doing so transforms depth from a barrier into a habitat. When the sperm whale slips beneath the surface, there is no dramatic transformation, no moment of tension. The body simply enters the medium it was designed for, and everything that follows flows naturally from that design, shaped by time, physics, and an environment that has never needed to explain itself. What sits inside the sperm whale's head is not just large, it is conceptually strange, because it represents one of those rare cases in biology where even after centuries of observation, humans struggled to understand what they were looking at. Long before scientists knew how deep sperm whales could dive, or how they navigated darkness, whalers were already cutting open these massive heads and finding something unexpected inside. A vast chamber filled with a pale, waxy substance that behaved neither like fat nor like oil in any familiar way. This substance, later named spermaceti, puzzled everyone who encountered it. It could be solid or liquid depending on temperature. It could be scooped, melted, poured, and refined. For centuries, humans understood this material better as a commodity than as a biological structure. Spermaceti candles burned brighter and cleaner than any other available light source in the pre-electric world, illuminating streets, ships, and homes. Yet the animal that produced it remained largely unknown, its internal design reduced to raw material rather than studied as a living system. Early theories about the purpose of the spermaceti organ reflected this gap in understanding. Some believed it existed to cushion the whale's head during violent encounters, imagining the sperm whale as a battering ram of the deep. Others thought it played a role in buoyancy alone, acting like a ballast tank that could be heated or cooled to control ascent and descent. There were even suggestions that it functioned as a massive lens for vision, focusing light in the darkness, despite the fact that light does not penetrate the depths where sperm whales hunt. These theories persisted not because they were convincing, but because the alternative was admitting ignorance. The scale of the structure demanded an explanation, and without direct observation of the whale's behavior at depth, speculation filled the silence. The spermaceti organ occupies most of the sperm whale's head, extending from the front of the skull back toward the brain, surrounded by a complex system of air sacs, connective tissue, and dense bone. Its size alone suggests importance. Evolution rarely tolerates such costly structures without reason. Maintaining this organ requires energy, material, and developmental precision. It is not a leftover trait or a biological accident. It is central to the sperm whale's way of life, even if that centrality took humans a long time to recognize. As technology improved and researchers began to piece together how sperm whales interact with their environment, a clearer picture emerged, though not a simple one. The spermaceti organ is not dedicated to a single function. It is a multi-purpose structure that integrates sound production, sound focusing, and subtle buoyancy effects in a way that no human-made system quite replicates. At the heart of this system is sound. In the deep ocean, sound is not just a sense, it is the primary way information moves. Light disappears within a few hundred meters of the surface, but sound travels efficiently through water, bending, reflecting, and carrying detail across long distances. The sperm whale has evolved to exploit this property to an extreme degree. The clicks it produces are among the loudest biological sounds ever recorded, sharp pulses that can travel kilometers through the water. These clicks are generated deep within the nasal passages, then shaped and focused by the spermaceti organ, before being projected forward into the ocean. The waxy material inside the organ acts as an acoustic lens, channeling sound into a narrow, powerful beam. This beam allows the whale to scan the darkness ahead, detecting prey, obstacles, and even subtle changes in the environment. The structure of the spermaceti organ, combined with the asymmetrical skull and surrounding air sacs, allows the whale to control not just the intensity of sound, but its direction and timing. This precision is essential. In a world where vision is useless, spatial awareness depends on interpreting echoes that return milliseconds after a click is emitted. The whale's brain processes these echoes, constructing a three-dimensional understanding of its surroundings. The spermaceti organ is therefore not passive storage. It is an active part of a sensory system that replaces sight with sound. Buoyancy still plays a role, but not in the simple way early theories imagined. Spermaceti changes density with temperature. As the whale dives, blood flow patterns and heat exchange can alter the temperature of the organ slightly, affecting its density. This can contribute to fine-tuned buoyancy control, helping the whale remain stable at depth without constant muscular effort. However, this effect is subtle, supporting the dive rather than driving it. The primary value of the organ lies in how it allows the whale to move and perceive efficiently in an environment where energy conservation is critical. Pressure adds another layer of complexity. At great depths, pressure affects not only external tissues but also internal structures. The spermaceti organ is enclosed within dense bone and connective tissue that can withstand compression, protecting the delicate acoustic system within. Its contents do not compress in the same way gases do, allowing it to function reliably even as surrounding pressures increase dramatically. This stability is essential for maintaining consistent sound production and reception across a wide range of depths. The fact that the organ continues to perform under such conditions is one reason it remained so mysterious for so long. Humans could examine it at the surface, but its true function only reveals itself in an environment we cannot enter easily. This disconnect between observation and function explains centuries of misunderstanding. For most of human history, sperm whales were encountered only briefly at the surface or violently during hunts. Their deep dives, their use of sound, their calm persistence in darkness were invisible. Without context, the spermaceti organ looked like an excess, a curiosity, something to be harvested rather than understood. Even as scientific inquiry replaced whaling, the challenge remained. Studying an organ designed to operate under extreme pressure in total darkness, miles below the surface, requires indirect methods and patient inference. Modern understanding has therefore emerged slowly, built from acoustic recordings, anatomical studies, and observations of diving behavior rather than direct experimentation. This slow accumulation of knowledge mirrors the animal itself. There was no single discovery that solved the mystery. Instead, clarity emerged as different pieces aligned. The shape of the skull, the structure of the nasal passages, the properties of the waxy material, the patterns of sound recorded in the ocean. Together, they revealed a system that is elegant precisely because it is integrated. The spermaceti organ is not an isolated feature. It is part of a larger design that ties anatomy, behavior, and environment together. This is why it remains so compelling. It is not just unusual, it represents a fundamentally different solution to perception and movement than anything humans experience directly. The sperm whale does not rely on light, landmarks, or visual memory. It relies on a constantly updated acoustic map generated by its own body. The massive head, once seen as ungainly, becomes the core of this system. Without it, the whale would be blind in a world that offers no light. Without it, the deep would be inaccessible. Understanding this organ also reframes the sperm whale's apparent calm. Producing such powerful sounds and interpreting their echoes requires focus and stillness. Excessive movement would interfere with perception. Aggression would waste energy. The whale's slow, deliberate demeanor is not personality, it is functional. It reflects an animal listening more than acting, gathering information from a world that reveals itself only through vibration and echo. The mystery inside the sperm whale's head therefore teaches a broader lesson about biology. Not all adaptations announce themselves clearly. Some only make sense when viewed in the context of an environment that remains largely hidden. The spermaceti organ puzzled scientists not because it was poorly designed, but because it was too well adapted to a place humans could not easily reach. It reminds us that many of nature's most refined solutions exist far from our experience, operating quietly and effectively without any need for recognition. And as understanding deepens, the sperm whale's head stops being a curiosity and becomes a key, unlocking access to a sensory world that lies beneath the surface, waiting to be interpreted rather than seen. A sperm whale's life does not begin in the deep, even though the deep will eventually define almost everything about it. Birth happens at the surface, in open ocean, far from land, where the water is deep enough that there is room to rise and breathe without obstruction. A calf enters the world tail first, an orientation that reduces the risk of drowning during birth, and within moments it must surface to take its first breath. That first breath is not instinctive in the way breathing is for land animals. It is learned almost immediately, guided by the mother, whose massive body stays close, steady, and calm. From the very beginning, survival depends on proximity. A newborn sperm whale is already enormous by human standards, measuring several meters in length and weighing close to a ton. Yet in the ocean, this size offers little protection. The calf is soft-bodied, inexperienced, and unable to dive deeply. For the first years of life, the surface world is its entire universe. Mothers play a central role during this period, not only by providing milk but by shaping how the calf experiences the ocean. Sperm whale milk is rich in fat, far denser than human milk, allowing calves to grow rapidly while conserving energy. Feeding is slow and frequent, with calves staying close to their mother's sides, learning the rhythms of breathing and movement simply by matching pace. There is no rush to independence. Unlike many animals whose young must fend for themselves quickly, sperm whales invest heavily in extended care. This strategy reflects the complexity of the skills required to survive later in life. Deep diving, sound navigation, and efficient hunting cannot be mastered quickly. They require time, practice, and observation. Family groups provide the structure within which this learning takes place. Sperm whales live in matriarchal units, composed primarily of adult females and their offspring. These groups can include multiple generations, with older females playing an important role in maintaining cohesion and transmitting knowledge. Calves are rarely alone. Even when mothers dive briefly, other females remain near the surface, effectively babysitting the young. This cooperative care reduces risk and allows mothers to balance feeding with protection. It also creates a social environment where calves are constantly exposed to the sounds, movements, and behaviors of others. Sound is one of the first tools calves begin to explore. Early vocalizations are simple and uncoordinated, lacking the precise timing and structure of adult clicks. Over time, through repetition and exposure, calves begin to refine these sounds. They learn not only how to produce clicks, but when to use them and how to interpret the echoes that return. This process unfolds slowly. Young whales do not immediately echolocate with the power or precision of adults. Their early dives are shallow, lasting only a few minutes and reaching modest depths. These dives serve less as hunting attempts and more as practice runs, allowing calves to experience pressure changes and darkness in controlled doses. As months turn into years, dive depth increases gradually. The body adapts alongside behavior. Muscles accumulate myoglobin, increasing oxygen storage. The cardiovascular system becomes more efficient. Lung collapse during dives becomes less disruptive as tissues adapt to repeated compression. None of this happens suddenly. Each stage builds on the previous one, reinforcing the idea that a sperm whale's life is defined by accumulation rather than transition. Mothers guide this process not through direct instruction, but through presence. Calves follow. They surface together. They dive together. Over time, the calf begins to anticipate movements, learning when to breathe, when to rest, and when to descend. This form of learning is subtle and continuous, embedded in daily routines rather than marked by milestones. It contrasts sharply with human expectations of development, where progress is often measured and accelerated. In the open ocean, patience is the primary currency. The long childhood of a sperm whale reflects the demands of its future environment. Deep diving is unforgiving. Mistakes can be fatal. A poorly timed ascent, a misjudged breath, or an inefficient movement pattern can quickly deplete oxygen reserves. By extending the learning period, sperm whales reduce the likelihood of such errors. Juveniles do not attempt the deepest dives until they are physically and cognitively prepared. Even then, early deep dives are shorter and more cautious than those of fully mature adults. Family groups provide stability during this extended development. They move together through the ocean, often following similar routes year after year. These routes are not fixed in the way terrestrial migration paths are, but they reflect an accumulated understanding of where food tends to be available and where conditions are favourable. Calves absorb this information implicitly. They are not memorising maps, but internalising patterns of movement and sound that will later guide them when they travel alone. Social bonds formed during this period are strong and long-lasting. Females often remain with their natal group for life, maintaining relationships that span decades. This continuity creates a living memory within the group, where experiences are shared indirectly through behaviour rather than instruction. When a group encounters a familiar region, the calm or alertness of older members provides cues to younger ones. In this way, learning extends beyond the individual and becomes a collective process. The open ocean offers no physical landmarks, but it is not featureless to a sperm whale. Soundscapes, temperature gradients, and subtle changes in water chemistry provide information that experienced individuals can interpret. Calves, over time, learn to recognize these cues. They learn the difference between the acoustic signatures of prey and the background noise of the deep. They learn how currents affect movement and how resting at the surface differs from resting at depth. Each lesson is layered onto the last, creating competence without haste. This slow accumulation of skill also shapes temperament. Young sperm whales are not frantic or impulsive. They mirror the measured behavior of adults, conserving energy and avoiding unnecessary exertion. Play does occur, particularly among juveniles, but even play is subdued compared to that of many other mammals. It often involves gentle contact, synchronized swimming, or experimenting with sound rather than chasing or rough physical interaction. This reflects an environment where excessive movement has costs and stillness often provides safety. Growing up in the open ocean means growing up without shelter. There are no reefs to hide behind, no vegetation to provide cover. Protection comes from awareness and group cohesion rather than concealment. Calves learn early to stay within the protective envelope of the group, positioning themselves where they can be seen and heard. This spatial awareness becomes second nature, forming the basis for later solitary life in males or continued group living in females. The contrast between early dependence and eventual independence is gradual rather than abrupt. Even as juveniles begin to dive more deeply and feed on their own, they remain connected to the group. Full independence, particularly for males, comes much later, after years of physical growth and experiential learning. By the time a young sperm whale is capable of surviving alone in the deep, it has already spent a significant portion of its life observing, imitating, and adapting. This extended developmental period reinforces the broader patterns seen throughout the species' biology. Nothing about the sperm whale is rushed. Growth is steady. Learning is layered. Skills are earned through repetition rather than instinct alone. This approach reflects an environment where stability matters more than speed, and where survival depends on minimizing error rather than maximizing output. From the first breath at the surface to the first tentative descents into darkness, a sperm whale's early life unfolds as preparation, not performance. Each stage builds quietly toward a future spent largely out of sight, in a world where experience is the most valuable resource an animal can possess. The first moments of a deep dive look deceptively simple from the surface, because nothing about them suggests the complexity unfolding inside the animal's body. A sperm whale finishes a series of slow breaths, each one deeper than the last, exchanging as much air as possible before leaving the surface behind. The final exhalation is angled forward, clearing moisture from the blowhole, followed by a long inhalation that fills the lungs without urgency. Then the whale arches its back, lifting the tail flukes into the air just long enough to pivot the body downward. Gravity and buoyancy take over, and the descent begins. In the first tens of meters, light still filters down from above, and the water feels familiar by ocean standards. Pressure increases, but not dramatically. Temperature drops slightly. At this stage, the whale is still very much connected to the surface world, but changes are already underway internally. Almost immediately after submerging, the heart rate begins to slow. What might be 40 or 50 beats per minute at the surface gradually drops to fewer than 10. In some cases, it slows to just a handful of beats per minute. This reduction is not a sign of stress. It is a controlled response that conserves oxygen by reducing circulation to non-essential tissues. Blood flow is redirected toward the brain and heart, while muscles and peripheral organs enter a state of low activity. As the whale passes a few hundred meters, light fades completely. There is no twilight zone for the sperm whale, no gradual dimming that the eyes could adapt to even if vision were useful. Darkness arrives fully and absolutely. At the same time, pressure begins to assert itself more strongly. With every 10 meters of depth, pressure increases by 1 atmosphere, and soon the weight of hundreds of atmospheres presses evenly against the whale's body. Air-filled spaces respond first. The lungs collapse safely, expelling air into reinforced passages where gas exchange no longer occurs. This collapse protects the whale from absorbing excess nitrogen, eliminating the risk of decompression sickness that plagues human divers. What would be dangerous for a human is routine for the sperm whale. Oxygen management during this phase relies less on the lungs and more on stored reserves. Oxygen bound to hemoglobin in the blood and to myoglobin in the muscles is released gradually as needed. Because the whale's muscles are rich in myoglobin, they can continue working even as blood oxygen levels fall. This allows the whale to move slowly and steadily without rapid fatigue. Metabolism shifts subtly, prioritizing efficiency over output. Cells reduce their energy demands, relying more on anaerobic pathways where necessary, tolerating brief periods without oxygen that would damage other mammals. As depth increases, temperature drops further. In the deep ocean, water temperature remains just above freezing, regardless of latitude. The whale's thick blubber layer insulates against this cold, maintaining a stable internal temperature. Heat loss is minimized not only by insulation, but by reduced blood flow to the skin and extremities. Warm blood stays concentrated near vital organs, while the outer layers cool slightly, creating a thermal gradient that slows heat exchange. Movement during the descent is minimal. The whale does not actively swim downward for long. Its body, carefully balanced in terms of density, allows it to sink with little effort once initial momentum is established. Occasional tail movements correct orientation or adjust speed, but much of the descent is passive. This stillness serves another purpose. Reduced movement lowers noise, improving the clarity of returning echoes when the whale begins to use echolocation more actively at depth. Sound becomes the primary connection to the surrounding world, mapping shapes and distances in a space without visual reference points. Typical dives vary depending on purpose. Shorter dives, lasting 20 to 30 minutes, may reach depths of several hundred meters. Longer foraging dives often exceed an hour and can reach depths of 1,000 meters or more. Records suggest that sperm whales are capable of descending even deeper, though such dives are likely rare and reserved for specific conditions. The deeper the whale goes, the more pronounced the physiological adjustments become. Heart rate remains low. Blood chemistry shifts to buffer changes in acidity caused by anaerobic metabolism. The body operates in a carefully controlled low-power mode, balancing the need to move and perceive with the need to conserve oxygen. Pressure at these depths is immense, yet the whale's tissues experience it uniformly. There are no rigid cavities that can collapse catastrophically, no weak points exposed to crushing force. Every aspect of the body has evolved to distribute pressure evenly, allowing function to continue uninterrupted. Darkness at depth is total. There is no sense of up or down that humans would recognize. Orientation depends on gravity, internal balance mechanisms, and the interpretation of echoes. The whale's brain integrates information from sound, subtle pressure changes, and internal sensors to maintain spatial awareness. This process is continuous and largely automatic. There is no conscious calculation, no hesitation. The descent unfolds as a smooth transition from one state to another. At depth, the whale may remain relatively still for extended periods, listening and scanning for prey. When movement occurs, it is deliberate and economical. Every motion is weighed against oxygen reserves. The environment itself remains constant. Unlike the surface ocean, where waves, currents, and temperature shifts create constant change, the deep is remarkably stable. Pressure, darkness, and cold remain consistent, allowing the whale to settle into a predictable rhythm. This stability is what makes such dives possible. The ascent, when it comes, is equally controlled. As the whale turns upward, buoyancy gradually increases. Collapsed lungs begin to re-expand as pressure decreases, but gas exchange does not resume until the whale nears the surface. Blood flow redistributes slowly, preventing sudden shifts that could cause injury. Heart rate increases gradually. The body transitions back towards surface physiology without abrupt changes. By the time the whale breaks the surface, much of the adjustment has already occurred. A series of deep breaths restores oxygen levels, clears carbon dioxide, and prepares the whale for the next cycle. This entire process, from surface to depth and back again, is not an extraordinary event for the sperm whale. It is routine. It happens repeatedly, day after day, year after year. What makes it remarkable is not the depth alone, but the calm efficiency with which the whale navigates such extremes. There is no drama in the descent, no visible struggle against pressure or darkness. The whale simply enters an environment it has been shaped to inhabit, and everything that follows unfolds according to a pattern refined over millions of years. The deep dive is not an act of endurance in the human sense. It is a state the whale passes into and out of, guided by anatomy, physiology, and an environment that rewards patience above all else. Once the sperm whale has passed beyond the reach of light, the ocean does not become empty or vague to it, because vision was never meant to be the primary way this animal understands its surroundings. In the deep, where darkness is complete and permanent, sound replaces sight so thoroughly that it becomes something closer to touch, a way of feeling the shape of the world at a distance. Echolocation in sperm whales is not an added sense layered on top of others. It is the dominant framework through which space, distance, movement, and even texture are perceived. The process begins with the production of clicks, short bursts of sound generated deep within the nasal passages and shaped by the massive structures inside the head. These clicks are not emitted randomly or continuously. They are produced in carefully timed sequences, with intervals that change depending on what the whale is doing. When searching broadly, clicks are spaced farther apart, allowing echoes from distant objects to return before the next sound is sent. When closing in on prey, the rhythm accelerates into a rapid series known as a buzz, providing near-instant feedback about position and movement. Sound travels through water far more efficiently than through air. it moves faster, farther, and with less loss of detail. In the deep ocean, where there are few obstacles and little background noise, a single click can propagate for kilometers. When that click encounters an object, whether it is a squid, a change in water density, or the seafloor itself, part of the sound reflects back. These returning echoes carry information encoded in subtle variations in timing, frequency, and intensity. To a human ear, a click might sound simple, even crude. To the sperm whale's auditory system, it is rich with detail. The brain interprets the delay between emission and return to calculate distance, the strength of the echo to estimate size, and the quality of the reflection to infer texture and shape. This is how sound becomes vision. Unlike sight, which depends on external light sources, echolocation is self-generated. The whale illuminates the world with its own signals, controlling both the source and the direction of perception. This control is essential in an environment where conditions never change. There is no dawn or dusk in the deep, no shifting shadows or colours to provide context. Sound offers consistency. It works the same way at any depth, in any darkness, across vast distances. The clicks produced by sperm whales are extraordinary not only in their function but in their power. They're among the loudest biological sounds ever measured, reaching intensities that, if produced in air, would be damaging to human ears at close range. In water, however, this power is necessary. High-intensity clicks allow echoes to return from far away, expanding the whale's perceptual field. This does not mean the whale is constantly broadcasting at maximum volume. Sound output is modulated, carefully, increasing when searching large volumes of water and decreasing when precision is needed nearby. This flexibility prevents sensory overload and conserves energy. The directionality of these clicks is equally important. The spermaceti organ and surrounding structures focus sound into a narrow beam projected forward. This beam allows the whale to scan specific regions of space without being overwhelmed by reflections from all directions. It is the acoustic equivalent of a spotlight, sweeping slowly through darkness. As the whale moves, this beam maps the environment ahead, updating continuously as echoes return. The whale does not see a flat image. It perceives a dynamic, three-dimensional representation that updates with each click. Objects are not just present or absent, they have depth, movement, and relative position. For prey detection, this system is remarkably effective. Squid, even those with soft bodies that reflect little sound, can be detected through subtle differences between their tissues and the surrounding water. Movement creates additional cues, as shifting positions alter echo patterns. The whale can track these changes in real time, adjusting its own movement accordingly. What is striking about this process is how little overt action it requires. The whale does not need to chase aggressively or react suddenly. It can remain almost motionless, letting sound do the work. This stillness enhances perception by reducing self-generated noise, allowing faint echoes to stand out clearly. In this way, echolocation shapes behavior as much as anatomy. The calm, deliberate movements observed in sperm whales are not signs of passivity. They are the optimal posture for listening. Sound also provides orientation in a world without landmarks. The deep ocean lacks visual cues, but it is not uniform acoustically. Temperature gradients, pressure layers, and the seafloor all reflect sound differently. Over time, sperm whales learn the acoustic signatures of familiar regions. These signatures are not maps in a human sense, but patterns of echo and reverberation that signal where the whale is relative to depth, bottom, and open water. This allows navigation across large vertical and horizontal distances without reference to sight. The replacement of vision with sound also influences social interaction. When sperm whales communicate, their vocalizations travel long distances, allowing individuals to remain in contact even when separated by hundreds or thousands of meters of water. In the deep, where visual contact is impossible, sound maintains cohesion. Family members can locate one another, coordinate movement, and share information without ever seeing each other. This acoustic connection persists regardless of depth or darkness, reinforcing the idea that sound is not merely a sense, but the medium through which sperm whale society exists. The power of sperm whale clicks has sometimes been misunderstood as aggression or excess. In reality, it reflects the physical demands of the environment. Sound weakens as it travels, and deep-water prey is often dispersed across large volumes of space. To detect such prey reliably, clicks must be strong enough to return usable echoes. This does not mean the whale is blasting indiscriminately. The intensity is purposeful, calibrated to the task at hand. The whale's auditory system is equally adapted to handle this intensity without damage, with specialized structures that protect sensitive tissues from self-generated sound. This balance between power and protection highlights the integration of the entire sensory system. Nothing operates in isolation. Sound production, sound reception, neural processing, and behavior all align around the same goal, making the deep ocean legible. For humans, darkness often implies uncertainty or danger. For the sperm whale, darkness is simply the default state of the environment, and sound fills the role that light never could. The whale does not miss vision. It does not compensate for its absence. Its world is complete as it is, structured by echoes instead of images. Understanding this reframes how the sperm whale's life unfolds at depth. The long descents described earlier are not blind journeys into emptiness. They are informed, perceptive movements guided by continuous streams of acoustic information. Every click sent into the water returns something, even if that something is simply confirmation of open space. This constant feedback allows the whale to move with confidence through an environment that humans would find profoundly disorienting. Sound as vision is therefore not a metaphor but a literal description of how the sperm whale experiences reality. It is a reminder that perception is not fixed across species. What seems essential to one animal may be irrelevant to another. In the sperm whale's case, abandoning reliance on light opened access to a vast stable habitat where few competitors could follow. The deep ocean, inaccessible and featureless to human eyes, becomes rich and structured through sound. And it is within this acoustic landscape that the sperm whale lives, hunts, navigates, and connects, guided not by what can be seen, but by what can be heard and interpreted. When sound replaces sight as the primary way of understanding the world, it also becomes the foundation for social life, because communication no longer depends on proximity or visual signals, but on patterns that can travel through darkness and distance. For sperm whales, this has led to a form of social organization that is subtle, stable, and deeply rooted in sound. The most recognizable element of this communication system is what researchers call codas, short sequences of clicks produced in specific rhythms and groupings. To a human listener, codas may sound repetitive or simple, but within sperm whale society they carry structure and meaning. Codas are not random noises. They are patterned with precise timing between clicks, and these patterns are repeated consistently within particular groups. Some codas consist of a few evenly spaced clicks. Others involve more complex rhythms with varying intervals. What makes codas remarkable is not just their existence, but their consistency across generations. Certain coda patterns are associated with specific family units or larger social clans, and these patterns persist over decades, even as individual whales are born and die. This persistence suggests that codas are learned rather than purely instinctive, passed from older whales to younger ones through exposure and repetition. In this way, sound becomes a carrier of social identity. A whale does not need to see another to recognize it as part of the same group. Hearing a familiar coda pattern is enough to establish connection. Patterns and rhythms in sperm whale communication extend beyond codas. Whales use a range of clicks for echolocation, but they also modulate these clicks in social contexts, adjusting timing, intensity, and sequence depending on the situation. Slow, regular codas may be exchanged when groups are resting or traveling together, maintaining contact across distances. More frequent or varied patterns may occur during reunions when groups that have been separated come back together. These exchanges are not chaotic. They follow recognizable structures that researchers can identify and categorize, even if the precise content remains unknown. The existence of dialects between different whale groups reinforces the idea that sperm whale communication is culturally shaped. Groups living in different regions, even when genetically similar, often use distinct coda patterns. These differences are not explained by environment alone. They persist even when groups overlap geographically, indicating that whales maintain their own acoustic traditions rather than converging on a single shared system. This is one of the strongest pieces of evidence for culture in a non-human species. Culture in this context does not imply art or symbolism in a human sense. It refers to behaviours and knowledge transmitted socially rather than genetically. In sperm whales, culture is embedded in sound. Young whales grow up immersed in the acoustic environment of their family group, hearing the same codas repeated over and over. Over time, these patterns become familiar, then habitual, and eventually defining. When a whale produces a particular coda, it is signaling membership, not unlike an accent or dialect in human speech. Cultural transmission of knowledge in sperm whales goes beyond communication patterns. Family groups exhibit consistent behaviors related to movement, feeding strategies, and responses to environmental conditions. These behaviors are not hardwired. They are learned through observation and shared experience. Older females in particular play a key role in this process. As matriarchs, they act as repositories of collective memory, having lived through changes in ocean conditions, prey availability, and even human activity. Their experience informs group decisions, such as when to move, where to feed, and how to respond to unfamiliar situations. This influence is rarely overt. There is no visible leadership display. Instead, younger whales follow, adjusting their behavior to match that of older, more experienced individuals. The matriarchal structure of sperm whale society supports this flow of knowledge. Groups are typically composed of related females and their offspring, forming stable units that can persist for decades. Males leave these groups as they mature, but females remain, reinforcing continuity. Within these units, cooperation is common. Mothers share care of calves, taking turns staying near the surface while others dive. This cooperative behavior reduces risk for the young and allows adults to balance feeding and protection more effectively. Communication plays a central role in coordinating these activities. Codas and other vocalizations help maintain group cohesion, even when individuals are at different depths. A whale diving hundreds of meters below the surface can remain acoustically connected to those above, ensuring that the group functions as a coherent whole rather than a collection of isolated individuals. Intelligence in this system is not expressed through problem-solving displays or tool use that humans might easily recognize. Instead, it appears in the ability to maintain long-term social relationships, to learn and reproduce complex communication patterns, and to adapt behavior based on shared experience. This intelligence is distributed rather than centralized. It does not reside solely in any one individual, but emerges from interactions within the group. The calm nature of these interactions is striking. There is little evidence of conflict or dominant struggles within family units. Social stability seems to be maintained through familiarity and shared history rather than competition. This stability aligns with the broader themes seen throughout sperm whale biology. In an environment where resources are dispersed and movement is costly, cooperation offers advantages over confrontation. Maintaining strong social bonds reduces uncertainty and increases efficiency. Sound-based communication makes this possible across distances and depths that would otherwise fragment groups. It allows sperm whales to remain socially connected in a three-dimensional environment that would challenge any visual system. The rhythms of communication also reflect the rhythms of life in the deep. There is no constant chatter, no background noise of social exchange. Vocalizations are purposeful, spaced out, and often followed by long periods of silence. Silence itself becomes part of communication, a shared state rather than an absence. This restraint reinforces the sense that sperm whale society operates on a different tempo than human social systems. It values continuity over novelty, stability over change. By framing intelligence in this way, sperm whale society challenges assumptions about what complex social behavior looks like. There are no elaborate displays, no visible hierarchies, no rapid exchanges. Instead, complexity is embedded in timing, pattern, and memory. Codas that sound simple carry layers of social meaning accumulated over generations. Family groups that appear loosely associated are in fact tightly knit through sound and shared experience. The ocean, vast and dark, does not isolate these animals. It connects them through acoustics, allowing culture to persist in a medium that never forgets a vibration. Understanding this aspect of sperm whale life brings together many of the elements already explored. Anatomy shaped for sound, dives structured around listening, and development focused on learning through proximity. Communication, culture, and family life are not separate from these processes. They are their continuation. Sound that once served to map the environment now also maps relationships. Echoes that once revealed prey now also signal belonging. In this way, the sperm whale's acoustic world becomes not just a sensory landscape, but a social one, carrying identity, memory, and connection through the deep. As sperm whales grow, a quiet divergence unfolds within their society, one that is not marked by conflict or ceremony, but by gradual distance, because adult males do not remain within the matriarchal family groups that shaped their early lives. This separation begins slowly, often when males are still juveniles, and reflects a biological and social pattern that has emerged over millions of years. While females stay with their natal groups for life, forming the stable social cores described earlier, males follow a different path, one defined by movement, solitude, and scale. The reasons for this split are not rooted in rejection or competition within the group. Instead, they arise from differences in body size, reproductive strategy, and ecological role. As males mature, they grow significantly larger than females, eventually becoming the largest individuals in the species. This increase in size changes their energetic needs and their interaction with the environment. Remaining within tightly knit family groups would offer fewer advantages as their bodies and behaviors diverge. Solitude in this context is not isolation, but specialization. Once males leave their family units, they begin a life that is far more wide-ranging than that of females. They travel through open oceans, often alone or in loose associations with other males, covering distances that span entire ocean basins. These migrations are not random wanderings. They follow broad patterns linked to food availability, ocean currents, and seasonal changes, even though the whales themselves are not constrained by surface conditions. Adult males are frequently found at higher latitudes than females, venturing into colder waters where prey can be abundant but conditions are harsher. Their large bodies provide advantages here. Greater mass means more stored energy, better insulation, and increased tolerance for cold. These traits allow males to exploit feeding grounds that would be less efficient or riskier for smaller whales. Life in the open ocean as a solitary male is markedly different from life within a family group. There is no constant acoustic exchange, no shared care of young, no collective movement. Instead, the male sperm whale operates largely on its own rhythms. It dives, feeds, rests, and travels according to internal cycles shaped by physiology and environment rather than by social coordination. Communication does not disappear entirely, but it becomes less frequent and more functional. Clicks are still used for echolocation, and occasional vocalizations may occur when other whales are nearby, but there is no ongoing social dialogue. Silence becomes the default state. This solitary existence does not imply loneliness in a human sense. For a sperm whale, solitude aligns with sensory and energetic efficiency. The deep ocean does not favor constant interaction. Listening requires stillness. Hunting requires focus. Movement across vast distances requires patience rather than company. Adult males embody this mode of existence, moving through the ocean as self-contained systems, carrying within them all the adaptations needed to survive independently. Their migrations can take them thousands of kilometers from their birthplace. Some males travel from tropical breeding regions to polar or subpolar feeding grounds, following gradients of productivity rather than fixed routes. These journeys unfold over years rather than seasons, with males spending long periods in high-latitude waters before gradually returning toward lower latitudes. Unlike many migratory animals, sperm whales do not rely on visual landmarks or fixed pathways. Navigation is guided by a combination of acoustic cues, oceanographic features, and internal orientation mechanisms refined over time. The return to breeding areas later in life is one of the few points where male and female paths intersect again. Mature males periodically travel back to regions where female groups reside, particularly during breeding periods. These visits are temporary. Males do not integrate into family units or form lasting bonds with offspring. Their role is limited but essential, contributing genetically before resuming their solitary journeys. This pattern reduces competition within groups and maintains social stability among females, while allowing males to maximize reproductive opportunities across a wide geographic range. The contrast between male and female life histories illustrates how a single species can support multiple strategies within the same environment. Females invest in continuity, social cohesion, and long-term care. Males invest in size, range, and endurance. Neither strategy is inherently dominant. Each complements the other, ensuring that the species as a whole can exploit a wide array of ecological niches. This division also minimizes overlap in resource use. While females and calves focus on certain feeding grounds and depth suited to their size and social structure, large males can target different prey concentrations and operate in regions less accessible to groups. Solitary males often dive as deeply as, or deeper than, females, using the same physiological mechanisms described earlier, but applying them over broader spatial scales. Their size allows them to take advantage of the large prey and to withstand longer periods between successful hunts. Encounters between solitary males and humans are rare and often brief. A single male surfacing in open ocean can go unnoticed for long periods, its presence marked only by a distant blow or the occasional sighting of a massive tail disappearing beneath the surface. This invisibility reinforces the idea that sperm whale life, particularly male life, unfolds largely beyond observation. The ocean provides both the space and the concealment needed for such a lifestyle. Importantly, the transition to solitude does not erase the learning acquired during early life. Males carry with them the knowledge absorbed within family groups: how to dive efficiently, how to interpret sound, how to manage energy and oxygen. What changes is not competence but context. Skills once used within a social framework are now applied individually. This continuity ensures that solitude does not mean vulnerability. It is simply a different expression of the same evolutionary solutions. The existence of solitary males adds depth to the broader picture of sperm whale society. It prevents the narrative from becoming one of uniform behavior or structure. Instead, it reveals flexibility within the species, an ability to support both intense social cohesion and long-term independence. This flexibility is part of what has allowed sperm whales to persist through environmental changes that have reshaped the oceans repeatedly. By distributing risk and opportunity across different life strategies, the species avoids dependence on any single mode of existence. In the quiet movements of solitary males traveling vast distances without accompaniment, the same themes recur: patience, endurance, and efficiency. These whales do not hurry toward destinations. They move through time and space with the same measured pace seen in every aspect of sperm whale life. Their journeys connect distant parts of the ocean, linking ecosystems that may never intersect at the surface. And while their paths rarely cross those of their former family groups, the shared origins remain embedded in behavior and biology, ensuring that even in solitude they are never truly disconnected from the larger story of the species. Feeding for a sperm whale is not an event marked by speed or spectacle, because in the deep ocean, food is not something that can be chased across distance. It is something that must be detected, approached, and taken with restraint. The primary diet of sperm whales consists of squid, animals that themselves are masters of darkness and depth, spending their lives suspended in cold water far below the surface. These squid are not schooling fish that flee in coordinated bursts, nor are they predictable grazers tied to specific locations. They are scattered, solitary, and often slow-moving, appearing in pockets of the deep that shift with currents and seasons. For a predator, this means that feeding is less about pursuit and more about patience. The sperm whale descends into the deep, not knowing exactly where prey will appear, only that sound will eventually reveal it. Echolocation, already central to navigation, becomes the primary hunting tool. Clicks sent into the water spread outward, scanning large volumes of space. When echoes return with the faint signature of soft-bodied prey, the whale adjusts its movement slightly, narrowing the acoustic beam, refining focus rather than accelerating. There is no rush to close distance quickly. speed would generate turbulence and noise, interfering with the clarity of echoes. Instead, the whale advances gradually, letting sound do most of the work. Energy efficiency governs every step. A deep dive represents a significant investment of oxygen and time, so each movement must be justified. Rather than chasing multiple prey items in quick succession, sperm whales often target individual squid, capturing them one at a time. This approach reduces wasted effort and minimizes the need for sudden bursts of activity. When a squid is located, the whale closes the remaining distance calmly, using fine-scale echolocation to track subtle movements. The final moments of capture are rarely violent. Squid are seized and swallowed whole, often headfirst with little resistance. Teeth play a minor role, helping to grip slippery bodies rather than tear flesh. This method of feeding aligns with the whale's anatomy and physiology. Swallowing prey, whole avoids prolonged struggle, conserving oxygen and energy. The digestive system is adapted to process large, protein-rich meals efficiently, extracting maximum nutritional value from each catch. Giant and colossal squid occupy a special place in human imagination, often portrayed as adversaries, locked in epic battles with sperm whales. In reality, encounters between these animals are rarely observed and almost certainly less dramatic than folklore suggests. Giant squid can reach impressive sizes, with long feeding tentacles and powerful mantles, but they are not built for sustained combat. Evidence of interactions comes primarily from the bodies of whales themselves. Many sperm whales bear circular scars on their skin, marks left by the suction cups lining squid tentacles. These scars vary in size and number, offering a physical record of past encounters. Some whales carry dozens of such marks layered over years, suggesting repeated interactions with large squid throughout their lives. These scars tell a story not of constant struggle, but of routine feeding encounters in an environment where both predator and prey are adapted to darkness and pressure. The presence of scars does not imply injury in the usual sense. The thick skin of sperm whales heals well, and scars accumulate without impairing function. Over time, they become part of the whale's external history, a visible reminder of the deep water life it leads. The fact that whales survive and thrive with these marks underscores how feeding fits seamlessly into their broader lifestyle. It is not an exceptional challenge, but a regular activity shaped by millions of years of coevolution. Energy-efficient hunting strategies extend beyond individual captures. Sperm whales often time their feeding dives to coincide with conditions that increase prey availability, such as changes in water temperature or currents that concentrate squid at certain depths. These patterns are not fixed but learned through experience. Older whales, particularly in social groups, appear to develop preferences for specific feeding grounds or times, returning to areas that have proven productive in the past. This learned behavior reduces the uncertainty inherent in hunting dispersed prey. Even solitary males, though operating independently, benefit from the cumulative experience gained earlier in life, carrying with them an understanding of where and when food is most likely to be found. The slow pace of feeding also reflects the metabolic realities of deep diving. Digestion itself requires energy and oxygen, so large meals are processed gradually. The whale's body balances the demands of digestion with the need to prepare for the next dive, distributing energy use over time rather than concentrating it in short bursts. This steady approach minimizes stress on physiological systems and supports longevity. Feeding, in this sense, is integrated into a continuous cycle of movement, rest, and recovery, rather than isolated as a distinct activity. The role of sound in feeding cannot be overstated. Echolocation does not simply locate prey, it shapes how the whale interacts with it. The acoustic signature of a squid differs from that of fish or other objects, allowing the whale to discriminate between targets before committing energy to capture. This selectivity is crucial in an environment where mistakes are costly. Chasing non-prey or misjudging distance could waste oxygen needed for ascent. By relying on sound, the whale reduces uncertainty, turning the deep into a space where feeding is predictable enough to support survival. The integration of anatomy, sound, and depth becomes especially apparent when considering how little visible movement accompanies successful feeding. From the surface, a feeding sperm whale may be completely undetectable. Even at depth, its movements are minimal, guided by internal feedback rather than external cues. This invisibility reinforces the idea that feeding in the deep ocean is a quiet process, unfolding beyond human awareness. It also explains why so much of what is known about sperm whale diets comes from indirect evidence: stomach contents of stranded whales, acoustic recordings, and the scars left behind by prey. Direct observation remains rare, not because feeding is dramatic, but because it is subtle and hidden. By handling the topic of feeding without drama, the sperm whale's role as a predator becomes clearer. It is not a creature defined by violence or dominance, but by efficiency and specialization. Its success lies in aligning its sensory systems, anatomy, and behavior with the realities of a slow, dark world. Squid are taken not through confrontation, but through quiet approach, guided by echoes rather than sight. Scars accumulate not as trophies, but as incidental records of a life spent repeatedly descending into depth. Feeding becomes another expression of the same principles that shape every aspect of the sperm whale's existence: patience, conservation of energy, and adaptation to an environment where haste offers no advantage. In this way, hunting and eating are not moments of intensity, but parts of a broader rhythm, woven into the long cycles of dive and surface, sound and silence that define life in the deep ocean. After feeding and long descents into darkness, rest becomes not a separate state but another carefully managed condition. Because in the open ocean there is no place where a sperm whale can stop completely. There is no ground to settle on, no shelter to retreat into, no moment when the environment pauses. Rest must happen within movement, and sleep must occur without surrendering awareness entirely. Sperm whales have solved this problem in a way that is as unusual as it is precise, developing resting behaviors that fit seamlessly into a life lived in 3 dimensions. One of the most striking of these behaviors is vertical rest, a posture that seems almost abstract when first observed. Instead of floating horizontally like many other whales, sperm whales often rest suspended head up and tail down, bodies aligned vertically in the water column. Groups of whales may gather in this posture, spaced a few body lengths apart, motionless except for subtle adjustments that keep them balanced. From a distance, they resemble a forest of dark pillars rising toward the surface, barely breaking the water with the tops of their heads. This position is not accidental. Vertical stillness minimizes movement, reducing energy expenditure and noise. It allows the whale to remain near the surface where breathing is easy, while also maintaining readiness to descend if needed. Resting in open water requires constant low-level control. Even when still, the whale must manage buoyancy, orientation, and breathing. Vertical posture helps stabilize the body naturally, with gravity and buoyancy working together rather than against each other. The whale does not sink or drift uncontrollably. It remains poised, balanced in a narrow range where minimal effort is required to stay in place. This efficiency is critical because rest is about conserving energy, not eliminating activity entirely. Sleep in sperm whales adds another layer of complexity. Like other cetaceans, they engage in unihemispheric sleep, a state in which one half of the brain rests while the other remains awake. This allows essential functions such as breathing, balance, and environmental awareness to continue uninterrupted. Unlike humans, sperm whales cannot afford total unconsciousness. They must surface regularly to breathe, monitor their position in the water, and remain alert to potential threats or changes in their surroundings. Unihemispheric sleep provides a compromise, allowing restorative processes to occur without fully disengaging from the world. During this state, one eye may close while the other remains open, corresponding to the resting and active hemispheres of the brain. Over time, the roles alternate, ensuring that both sides receive rest. This alternating pattern unfolds quietly, without any visible markers beyond subtle changes in posture or eye position. To an observer, a resting sperm whale may appear completely still, yet internally it is cycling through complex neurological states that balance rest and vigilance. Safety during rest is maintained through a combination of group behavior and environmental awareness. In family groups, whales often rest together, maintaining acoustic contact even when silent. The presence of others reduces individual risk, as multiple animals can detect changes in the environment more effectively than one alone. Even solitary males, though resting independently, rely on the same principles of stillness and awareness. They choose locations and depths that minimize disturbance, often resting near the surface where they can breathe easily while remaining alert. The ocean itself plays a role in facilitating rest. In the open sea, away from coastlines and human activity, conditions can be remarkably stable. Currents are slow, noise levels are low, and disturbances are infrequent. This stability allows whales to enter extended periods of rest without constant interruption. However, rest is rarely deep or prolonged in a single stretch. Instead, it occurs in intervals woven between dives, feeding, and travel. Over the course of a day, these intervals accumulate, providing sufficient recovery without requiring long continuous sleep. The vertical resting posture also serves an acoustic function. By minimizing movement and maintaining orientation, whales reduce self-generated noise that could interfere with listening. Even while resting, the active hemisphere of the brain continues to process sound, maintaining a basic awareness of the surrounding acoustic environment. This means that rest does not equal disconnection. The whale remains part of the soundscape, able to respond if necessary. This constant low-level listening reinforces the idea that sound governs every aspect of sperm whale life, from hunting to social interaction to rest. The calm associated with these resting behaviors is not the result of tranquility in a human sense, but of precision. Every element of the posture and neurological state is tuned to the demands of the environment. Vertical stillness is not chosen because it looks peaceful, but because it works. Unihemispheric sleep is not a compromise born of limitation, but a solution refined over evolutionary time. Together, these behaviors allow sperm whales to recover physically and neurologically without ever becoming vulnerable. Observations of resting sperm whales often leave a strong impression because they challenge expectations. An animal of such size, capable of diving to extreme depths and producing powerful sounds, appears completely motionless, suspended in open water. There is no visible effort, no sign of strain. This contrast highlights the underlying theme that has emerged repeatedly. Success in the deep ocean does not depend on constant action. it depends on knowing when to be still. Rest, in this context, is not an absence of behavior but an active state, managed with the same care as diving or feeding. The whale's body remains engaged, maintaining balance and readiness, while the brain cycles through rest in a controlled manner. This balance supports longevity, allowing sperm whales to maintain demanding lifestyles over decades. It also reinforces social cohesion, as shared resting periods strengthen group stability and reduce stress. In a world without fixed reference points, where movement is costly and mistakes can be fatal, the ability to rest safely is as important as the ability to hunt or navigate. Vertical stillness and unihemispheric sleep provide that ability, integrating rest into the continuous flow of life in the open ocean. The result is a pattern of living where activity and stillness are not opposites, but complementary states, each enabling the other. Time moves differently for an animal that spends its life crossing entire ocean basins and diving into darkness where the sun has never reached. And this difference becomes most apparent when looking at how long sperm whales live and how slowly their lives unfold. Estimates vary because no one has ever followed a single individual from birth to death in the open ocean, but evidence from long-term observation, genetics, and whaling records suggest that sperm whales commonly live 60 to 70 years, with some individuals likely reaching 80 or more. This places them among the longest-lived mammals on Earth, comparable to elephants and some species of baleen whales, and far beyond the lifespan of most land predators. What matters more than the number itself is what that number allows. A long life creates space for slow growth, extended learning, and social bonds that develop over decades rather than seasons. From the moment a calf is born, time stretches outward, not as a series of urgent milestones, but as gradual accumulation of experience. Physical growth alone takes years. A sperm whale calf may double in size within its first year, but reaching full adult length and mass takes well over a decade, and in males, true physical maturity can take several decades. This slow growth reflects the energetic realities of the deep ocean. Food is abundant enough to sustain life, but not abundant enough to fuel rapid development. Instead of growing quickly and reproducing early, sperm whales invest in durability. Their bodies are built to last, their tissues maintained and repaired over long spans of time, their metabolism tuned for efficiency rather than speed. Aging in sperm whales appears to follow the same pattern of gradual change. Teeth, which are not used for chewing but still record layers of growth like tree rings, show steady deposition year after year, allowing scientists to estimate age long after the animal's death. These records suggest that sperm whales do not experience rapid senescence. There's no sudden decline after a brief prime. Instead, physical capability and social relevance extend well into later life. Older females remain central to family groups, carrying knowledge accumulated over decades. Their value is not tied to strength or speed, but to memory and experience, traits that only time can produce. Learning too unfolds at a measured pace. Young whales do not simply inherit survival skills genetically. They acquire them through observation, imitation, and repeated practice. Diving, navigation, prey recognition, and social communication all improve gradually. Mistakes are part of the process, and the long lifespan provides room for those mistakes without catastrophic consequences. This slow learning is only possible because sperm whales are not under constant pressure to reproduce quickly. Females give birth every 4 to 6 years, sometimes longer, investing heavily in each calf. Reproduction is spaced out, reducing strain on the mother and increasing the survival chances of each offspring. Over a lifetime, A female may raise only a handful of calves, but each one benefits from years of attention and guidance. This reproductive strategy contrasts sharply with animals that produce many offspring quickly, relying on numbers rather than care. Here, patience replaces urgency. The pace of life is shaped by the ocean itself. In the deep sea, conditions change slowly. Temperature is stable, daylight cycles are muted, and seasonal variation is less pronounced than on land. This stability favors long-lived species with slow life histories. Rapid reproduction and short lifespans make sense in environments that change quickly or unpredictably. In the open ocean, especially at depth, consistency rewards endurance. Sperm whales are products of that consistency. Their bodies and behaviors are tuned to a world where nothing happens fast, and survival depends on being able to persist rather than outcompete. Longevity also alters how risk is managed. An animal that expects to live for decades cannot afford frequent high-risk behavior. Injuries that might be survivable for a short-lived species become significant liabilities over a long life. This helps explain the calm, deliberate nature of sperm whale behavior. They do not waste energy on unnecessary speed or aggression. Movements are measured, dives planned, and social interaction stable. Even encounters with large prey or unfamiliar situations are approached methodically. Over time, this conservatism pays off, reducing cumulative risk and supporting long-term survival. Aging individuals likely experience changes in physical capacity, as all animals do. But these changes occur slowly enough to be accommodated within social structures. An older whale may dive slightly less deep or move slightly less often, but within a group these changes do not remove its relevance. Knowledge becomes the primary contribution. Knowing where prey is likely to be found, how conditions shift across seasons, and how to respond to rare events such as storms or unusual oceanographic changes is information gathered only over many years. This transforms age from a liability into an asset. From a human perspective, it can be difficult to fully grasp what such a timescale means. A single sperm whale may experience multiple generations of humans, witnessing changes in ocean noise, shipping traffic, and climate conditions that occur gradually over its lifetime. Its own sense of time, shaped by daily dives and long migrations, is likely very different from ours. Days are marked by cycles of descent and ascent rather than clocks. Years pass not as calendars, but as repeated journeys through familiar routes. Decades become layers of memory embedded in social bonds and learned behaviors. This extended lifespan places sperm whales outside human timescales. They're not ancient in a geological sense, but they are old enough to make human lifespans feel brief by comparison. This perspective reinforces the documentary's slow rhythm. Understanding sperm whales requires stepping out of urgency and into patience. Their lives cannot be summarized by dramatic moments alone. They are defined by continuity, by the accumulation of small repeated actions over long periods. Feeding dives repeated thousands of times, migrations traced year after year, calves raised slowly into independent adults. Nothing is rushed, and nothing needs to be. Longevity is not just a biological fact for sperm whales. It is the foundation of their entire way of life. It allows intelligence to deepen, culture to persist, and social structures to remain stable across generations. It shapes how energy is used, how risks are assessed, and how learning is valued. In a world that often feels dominated by speed and immediacy, sperm whales represent a different model of success, one built on time itself. Human contact enters the sperm whale story quietly and unevenly, because for most of its existence the species lived entirely outside human awareness, moving through oceans that were rarely crossed and never understood. When humans first began encountering sperm whales regularly, it was not through observation but through pursuit. Historical whaling brought sperm whales into the human world not as animals to be studied, but as sources of oil, bone, and wax. Early whalers knew little about the lives of the whales they hunted. They saw only fragments, a massive head breaking the surface, a powerful tail disappearing beneath the waves, long hours of waiting punctuated by brief, violent encounters. Much of what was recorded during this period reflects human needs rather than whale behaviour. Logs described size, yield, and danger, but not social structure, communication, or deep diving. The spermaceti organ, so central to the whale's biology, was reduced to a commodity long before its function was understood. This era shaped human perceptions of sperm whales as formidable and mysterious, not because of what they did, but because of what humans could not see. As whaling intensified, populations declined, and with them opportunities to observe sperm whales in their natural state. Yet even during this period, the whales themselves did not fundamentally change their behaviour toward humans. They did not adapt to hunt ships or attack systematically. Encounters remained incidental, driven by overlap rather than interaction. This pattern has continued into the modern era. With the decline of commercial whaling and the rise of scientific research, encounters between humans and sperm whales shifted from exploitation to observation. Modern scientific encounters are characterized by distance and restraint. Researchers follow whales at the surface, deploy acoustic instruments, and tag individuals temporarily to record dive profiles and movement patterns. These methods are designed to minimize disturbance, acknowledging that sperm whales are most themselves when left largely alone. Data collected in this way has transformed understanding of their lives, revealing dive depths, social structures, and communication patterns that were previously inaccessible. Yet even now, direct interaction remains rare. Scientists do not observe sperm whales feeding at depth. They infer behaviour from sound, movement, and physiology. This indirect relationship mirrors the broader dynamic between humans and sperm whales. We learn about them without fully entering their world. One of the most significant changes humans have introduced into that world is sound. Ships, sonar, and industrial activity have altered ocean soundscapes, especially near major shipping routes. For an animal that relies on sound as its primary sense, this change is not trivial. However, sperm whales appear remarkably tolerant of many forms of human-generated noise. This does not mean they are unaffected, but their responses tend to be subtle rather than dramatic. Whales may adjust dive timing, alter vocalization patterns, or move away from particularly noisy areas, but they rarely show overt distress. Part of this tolerance may stem from the frequency range of their clicks, which differs from much of the noise produced by ships. Another factor is their long evolutionary history in acoustically dynamic environments. Natural ocean sounds, from storms to seismic activity, have always been present. The sperm whale's sensory system is adapted to filter and prioritize signals, focusing on what matters most. This does not render human noise irrelevant, but it helps explain why sperm whales largely ignore human presence. Ships passing overhead are often treated as background rather than objects of interest. The whales do not investigate or follow them. They do not display curiosity or avoidance unless noise levels become extreme. To a sperm whale, a ship is not a social partner or a predator. It is simply another sound source moving through the water. This indifference can feel surprising from a human perspective, where large animals are often expected to react strongly to our presence. In reality, sperm whales operate on a scale that dwarfs most human activity. Their attention is directed downward into the deep, not upward toward the surface. The human world exists mostly above them, both physically and perceptually. Even when whales surface near boats, their focus appears inward, on breathing and recovery rather than interaction. The lack of sustained engagement reflects a fundamental difference in priorities rather than a lack of awareness. Historical accounts sometimes describe sperm whales as aggressive or unpredictable, but modern understanding suggests these impressions arose from rare, context-specific situations, often involving injured or harassed animals. In their normal state, sperm whales show little interest in confrontation. Their evolutionary success does not depend on responding to unfamiliar surface objects. It depends on maintaining routines that have worked for millions of years. Human encounters, whether historical or modern, represent brief interruptions rather than defining features of their lives. By placing these encounters in context, the sperm whale story remains centered on the animal rather than on human impact. Humans have influenced sperm whale populations and environments, but they have not reshaped the fundamental behaviors explored throughout this documentary. Deep diving, sound-based perception, social structure, and slow life histories persist regardless of human presence. This continuity underscores a broader point. Sperm whales are not reactive animals. They do not constantly adjust to every change in their surroundings. Instead, they rely on systems designed for stability and endurance. This approach has allowed them to persist through dramatic changes in ocean conditions long before humans appeared. Understanding this relationship without guilt or activism allows for a clearer view of the species itself. The sperm whale is neither victim nor antagonist in the human story. It is an organism following its own path, intersecting with ours only occasionally. Scientific study has expanded knowledge, but it has not altered the whale's priorities. Ship noise has changed soundscapes, but it has not replaced the whale's reliance on echolocation. Historical whaling reduced numbers, but it did not erase the behaviours encoded in the species' biology. By maintaining a neutral perspective, the focus remains on how sperm whales live, not on how humans feel about them. Encounters with the human world become another layer of context rather than the central narrative. They remind us that much of the sperm whale's existence unfolds beyond observation, shaped by forces and timescales that operate independently of human attention. The whale does not seek recognition or avoidance. It continues to dive, listen, feed, rest, and migrate as it always has, largely indifferent to the surface world drifting above. Beyond their individual lives, sperm whales influence the ocean in ways that are quiet, diffuse, and easy to miss. Because their impact is not concentrated in dramatic events, but spread across space, depth, and time. Every deep dive connects layers of the ocean that would otherwise remain largely isolated from one another. When a sperm whale descends thousands of meters to feed, it enters regions where nutrients are abundant but locked away in darkness, unavailable to surface ecosystems. Squid and other deep-sea organisms accumulate minerals such as iron and nitrogen in these depths, incorporated into their bodies through food webs that never see sunlight. When a whale feeds on this prey and later returns to the surface, it carries those nutrients upward inside its own body. Digestion does not simply remove energy. It transforms deep sea material into forms that can be released in surface waters through waste. This process, often referred to as nutrient cycling, operates continuously and without intention, yet its effects ripple outward. The whale pump, a term used to describe how large marine animals redistribute nutrients vertically, is particularly pronounced in deep-diving species like sperm whales. By feeding at depth and defecating near the surface, whales release iron-rich waste into sunlit waters where phytoplankton grow. Phytoplankton form the base of marine food webs, supporting everything from microscopic zooplankton to large fish. In many regions of the ocean, iron is a limiting nutrient, meaning that even small additions can significantly boost productivity. A single sperm whale, through its normal daily activity, contributes to this fertilization process repeatedly over decades. Multiplied across populations and generations, the effect becomes substantial. Carbon movement through ecosystems is also influenced by sperm whales, though not in simple or direct ways. Carbon enters the ocean through atmospheric exchange and is incorporated into living organisms through photosynthesis. When phytoplankton grow, they absorb carbon dioxide, converting it into organic matter. Some of this carbon sinks when organisms die, becoming part of the deep-sea carbon pool. Sperm whales interact with this cycle by consuming deep-sea prey that already contain carbon and redistributing it. Some carbon is released back into surface ecosystems through waste, while some remain sequestered in deep waters when whales die and their bodies sink. These whale falls become concentrated sources of carbon and nutrients on the seafloor, supporting unique communities of organisms for decades. In this way, sperm whales participate in both the upward and downward movement of carbon, acting as connectors between surface and depth. The importance of large animals in ocean health becomes clearer when viewed through this lens. Size allows sperm whales to move large quantities of material across ecological boundaries that smaller animals cannot cross. Their long lifespans amplify this effect, turning countless small contributions into a sustained influence over time. Unlike episodic events such as storms or blooms, the whale pump operates steadily, day after day, without pause. It does not depend on seasons or cycles visible at the surface. It depends on the persistence of animals whose lives are measured in decades. This persistence adds resilience to ocean systems, buffering them against change by maintaining pathways for nutrient flow. Importantly, these ecological roles do not require the whales to behave in any special way. They emerge naturally from feeding, diving, and digestion. The sperm whale does not manage ecosystems consciously. It simply lives according to its biology, and the ocean responds. This perspective avoids exaggeration while still recognizing significance. Sperm whales are not keystone species in the sense that removing them would immediately collapse ecosystems, but their presence enhances productivity and connectivity in subtle ways that accumulate over time. Their absence would not be catastrophic overnight, but it would quietly diminish the ocean's capacity to circulate nutrients efficiently. Large animals also shape ecosystems through physical presence. The movement of a sperm whale displaces water, mixing layers slightly as it ascends and descends. Though small compared to currents, this mixing occurs repeatedly, and at scales few other organisms reach. Over long periods, even minor mixing contributes to the overall dynamism of the ocean, preventing complete stratification. Additionally, whale falls create islands of life on the seafloor, supporting specialized species that depend entirely on the sudden availability of organic material. These communities exist nowhere else, and persist only because large animals occasionally die at sea. In this way, sperm whales influence not just open water ecosystems but benthic ones as well. Understanding this role adds a broader context to everything that has come before. Deep dives, slow feeding, long lifespans, and even solitary migrations all feed into these ecological processes. The whale's calm pace becomes part of a larger rhythm that includes nutrient flow and carbon cycling. There is no need to frame this as moral responsibility or environmental obligation. It is simply how the system functions. Large, long-lived animals integrate processes that would otherwise remain fragmented. By moving between depths and regions, sperm whales help maintain the continuity of the ocean as a single, interconnected system, rather than a collection of isolated layers. This big-picture view reinforces the idea that significance does not always announce itself. The sperm whale does not dominate the ocean through force or numbers. Its influence is proportional to its patience and endurance. Each dive, each feeding event, each resting period contributes incrementally to a larger pattern. Over years and decades, these increments matter. They shape productivity, support food webs, and influence how carbon moves through the marine environment. Recognizing this role adds meaning without preaching, grounding the whale's importance in observable processes rather than symbolic value. It reminds us that the ocean's health is not maintained by any single factor, but by the accumulation of countless interactions unfolding over long timescales. In this context, the sperm whale stands as one thread in a vast network, its movements linking dark depths to sunlit surfaces, its life bridging biological and geological rhythms. Studying sperm whales requires accepting that much of what matters most happens out of reach, because these animals spend the majority of their lives far below the surface, beyond direct observation, in a part of the ocean that resists intrusion. Scientists do not watch sperm whales in the way they might study terrestrial animals, following individuals continuously or observing social interactions in real time. Instead, knowledge is assembled from fragments, gathered during brief windows when whales surface, leave acoustic traces, or carry instruments for a limited time. This indirect approach shapes everything we know about them and explains why uncertainty remains even after decades of research. Early scientific study relied heavily on whaling records and stranded individuals, offering anatomical detail but little insight into behaviour. It was not until the development of underwater acoustics that researchers began to access the whale's primary sensory world. Hydrophones lowered into the ocean revealed patterns of clicks and codas travelling through deep water, allowing scientists to detect whales without seeing them. These recordings transformed understanding, showing that sperm whales were present even when the surface appeared empty. Sound became the first reliable window into their hidden lives. Tagging technology added another layer. Modern tags are attached temporarily using suction cups, designed to fall off after hours or days. These devices record depth, movement, orientation, and sometimes sound, providing detailed profiles of individual dives. From these data, scientists reconstruct descent rates, dive depths, rest periods, and feeding behaviour. Yet each tag represents only a short chapter in a whale's long life. Once the tag detaches and floats to the surface for retrieval, the whale disappears again, resuming its routines unseen. Tracking deep-diving animals presents challenges that do not exist for surface-oriented species. Satellite tracking works only when an animal surfaces long enough for a signal to transmit, and sperm whales surface briefly between dives. Even when data are collected, they represent snapshots rather than continuous records. Researchers infer patterns by compiling many such snapshots across individuals and years, building statistical pictures rather than narrative ones. This method reveals averages and tendencies but leaves room for variation that cannot be easily documented. Acoustic monitoring helps fill some gaps. Fixed listening stations on the seafloor or drifting platforms record whale sounds over long periods, revealing presence, movement patterns, and seasonal changes in activity. From these recordings, scientists can map broad-scale distribution and migration without ever seeing the animals. However, acoustic data lack visual context. They tell when whales are present and vocalizing, but not what they are doing in detail. Silence can mean absence, rest, or focused hunting, and distinguishing between these states requires interpretation rather than direct evidence. Observation is further limited by the ocean itself. Light, pressure, and distance constrain what equipment can do. Cameras struggle in darkness and extreme pressure. Submersibles cannot follow whales to full depth for extended periods. Even remotely operated vehicles are limited by tethers and energy constraints. As a result, many behaviors are inferred rather than witnessed. Feeding interactions with giant squid, for example, are known primarily from scars, stomach contents, and acoustic patterns, not from direct visual documentation. This absence of direct observation is not a failure of science, but a reflection of the environment. The deep ocean is vast, dark, and difficult to access, and sperm whales are adapted to exploit exactly those qualities. Their tendency to disappear is not incidental. It is central to their survival strategy. They're most active where humans cannot follow easily, and even when they surface, they do so briefly, offering little opportunity for prolonged study. This creates a situation where mystery persists despite technological progress. Each advance reveals new details while highlighting how much remains unseen. Scientists working in this field often speak of patience rather than discovery. Progress comes slowly, through accumulation rather than breakthrough. Long-term studies spanning decades are required to detect changes in population structure, communication patterns, or migration routes. Individual researchers may devote entire careers to answering a single question, knowing that complete answers may remain out of reach. This slow pace mirrors the lives of the whales themselves, reinforcing the alignment between subject and method. The limitations of observation also shape interpretation. Researchers are careful to avoid overgeneralizing from limited data, acknowledging uncertainty where it exists. This caution preserves the integrity of the science, but also leaves room for wonder. Not knowing everything becomes part of the story. The sperm whale remains partially hidden, not because it is unknowable, but because it inhabits a world that operates on different terms. Studying an animal that disappears requires humility, an acceptance that understanding will always be incomplete. This acceptance builds a quiet scientific mystery, one that does not rely on dramatization, but on recognition of scale and distance. The whale's world is not designed to be observed continuously, and science adapts by listening, recording, and waiting. Each piece of data adds to a mosaic that is never finished, always open to revision as new methods emerge. In this way, the study of sperm whales becomes a dialogue between curiosity and restraint. Humans seek to know, but the ocean sets boundaries. Within those boundaries, knowledge grows slowly, shaped by sound, statistics, and inference rather than sight. This process respects the whale's autonomy, allowing it to remain largely unseen while still influencing understanding. The result is a body of knowledge that feels provisional, grounded in evidence yet open-ended. Much remains hidden, not as a failure, but as a reminder that some lives unfold beyond continuous observation, leaving traces rather than narratives. Even after decades of research and thousands of hours of recordings, the sperm whale remains defined as much by what is unknown as by what has been learned. Because the deeper science goes, the more clearly the limits of understanding come into view. There are still basic questions without firm answers, not because they have been neglected, but because the animal's life unfolds in places where observation becomes fragmentary and indirect. One of the most persistent open questions concerns the full range of sperm whale migrations. Scientists know broad patterns, such as males moving toward higher latitudes and females remaining closer to equatorial and temperate regions, but the detailed routes taken across entire lifetimes remain largely unmapped. Whales may follow oceanographic features that shift slowly over years, such as deep currents, thermal layers, or prey distributions that do not align neatly with surface geography. Tracking such movement would require continuous monitoring over decades, something current technology cannot yet provide. Even satellite tags, among the most advanced tool available, offer only brief glimpses before they detach or fail. Another uncertainty lies in behavior at extreme depths. While recorded dives have reached well over 1,000 meters, there is evidence suggesting sperm whales may sometimes descend even deeper. What happens during these deepest dives is mostly inferred rather than observed. Scientists do not know how prey selection changes at these depths, how sound behaves under such pressure, or how whales adjust physiology beyond known limits. Similarly, the exact mechanics of echolocation at long range remain partially understood. While it's clear that clicks are powerful and directional, how whales process complex echo information in cluttered or variable environments is still an open area of study. The brain structures involved are known, but how perception is constructed moment by moment remains speculative. Social behavior also contains gaps. Coders have been categorized and compared across populations, but their precise meanings are unknown. Researchers can identify patterns and associations, but whether coders convey specific information beyond identity, such as emotional state or situational context, is still debated. There are hints of complexity, such as changes in rhythm during certain interactions, but without controlled conditions or direct observation, interpretation remains cautious. Similarly, the full extent of cultural transmission is not fully mapped. Scientists know that vocal patterns persist across generations, but how other behaviors, such as migration timing or feeding preferences, are passed on remains difficult to document. Aging introduces further unknowns. While lifespans can be estimated, the experience of old age in sperm whales is not well described. How physical decline, if it occurs, affects dive behavior, social role, or survival is not clearly understood. There is evidence that older females remain central within groups, but how aging males fare in solitary life is less certain. Do they continue long migrations at the same scale? Do their diving capacities diminish gradually, or remain stable until late in life? These questions remain open. Even mortality is poorly understood. Many sperm whales die at sea, their bodies sinking and disappearing without record. Strandings offer limited insight, but they represent atypical circumstances rather than normal life endings. The limits of current technology shape all of these uncertainties. Cameras cannot follow whales for long periods at depth. Tags record data but cannot capture context or interaction beyond movement and sound. Acoustic monitoring reveals presence but not intention. Each method illuminates one aspect while leaving others in shadow. Progress comes from combining these partial views, but even together they cannot produce a complete picture. Honest science accepts this incompleteness. Rather than filling gaps with assumption, researchers acknowledge where evidence ends. This approach avoids false certainty and preserves space for future discovery. It also aligns with the nature of the animal itself. The sperm whale is not elusive by accident. Its life is structured around depth, darkness, and distance, conditions that naturally limit observation. What remains unknown is not a failure of inquiry, but a reflection of scale. Some lives unfold beyond continuous measurement, leaving traces rather than full narratives. In this way, uncertainty becomes part of understanding. Knowing that there are unanswered questions reinforces the broader themes already explored: patience, endurance, and respect for environments that resist simplification. The sperm whale continues to dive beyond reach, communicate in patterns not fully decoded, and migrate along routes only partially traced. Science follows as closely as it can, listening, recording, and inferring, aware that some aspects will remain unseen. This balance between knowledge and mystery is not something to be resolved, but something to be maintained, because it keeps understanding grounded and open, mirroring the deep ocean itself. At the surface, a sperm whale breathes a few times, unhurried and steady, exchanging air with an atmosphere that plays only a small role in its life, and then the body tilts, the tail lifts, and the familiar movement begins again, a return rather than a departure. Because for the whale, the surface is a pause and the deep is where continuity lives. The descent carries no sense of ending. It is a repetition of something that has happened thousands of times before and will happen thousands of times again. Above the whale, the surface world continues with its own rhythms, shaped by light, weather, and human activity, while below, darkness waits in the same state it has always been, unchanged by events at the surface. These parallel worlds rarely intersect in meaningful ways. Sound travels between them, pressure connects them, but experience does not. The whale moves downward through layers of water that humans cross only briefly or not at all, entering a space where time feels slower, because nothing interrupts it. Each dive renews the same pattern. Heart rate slows, movement becomes economical, sound takes precedence over sight, and the body settles into a state refined by millions of years of repetition. There is no climax to this motion, no destination that resolves the journey. Depth is not a goal, but a condition. When the whale reaches feeding depth, it listens, moves, feeds, and waits, then eventually turns upward, not because something is finished, but because the cycle requires air. The ascent mirrors the descent, pressure easing, lungs re-expanding, light returning gradually, until the surface appears again, briefly, before the next dive begins. Above, ships pass, clouds shift, and coastlines change, often unnoticed by the whale below. Below, squid drift, currents flow, and sound carries across distances measured in kilometers rather than meters. These worlds coexist without merging, each complete within its own rules. The sperm whale belongs to the lower, on, not as a visitor but as a permanent resident whose brief appearances at the surface are functional rather than expressive. Its life does not build toward a final moment or a narrative conclusion. Calves grow into adults, adults age and eventually disappear, and new calves take their place, while the larger pattern remains intact. Family groups continue their movements. Solitary males trace long arcs across oceans, and the deep remains a constant presence beneath them all. Nothing in this process suggests completion. Knowledge passes from one generation to the next through sound and proximity, not instruction. And the ocean receives these lives without recording them in ways humans can easily read. A whale that dives today follows routes shaped by ancestors it never met, responding to conditions that have changed slowly enough to feel permanent. Even human influence, which seems rapid and disruptive at the surface, arrives as distant noise below, filtered and absorbed rather than confronted directly. The whale does not pause to interpret these changes, It continues to dive, to listen, to feed, to rest. Because those actions remain effective, continuity is maintained not by resistance or adaptation in a dramatic sense, but by persistence. The sperm whale does not need to be aware of its role in nutrient cycles, carbon movement, or ocean health. These effects arise naturally from its existence, unfolding quietly as it lives. Its influence is not announced. It accumulates. A dive completed today resembles one completed decades ago, not because nothing has changed, but because the whale's way of moving through the world remains sufficient. The deep ocean does not demand novelty. It rewards reliability. As long as the whale can descend, listen, and return, its life continues in balance with its environment. This balance does not resolve into an ending that can be marked or summarized. When a whale disappears for the last time, sinking without surfacing again, the ocean absorbs it, redistributing its substance and leaving no clear boundary between life and aftermath. Other whales continue to dive nearby, unaware of the individual loss, following patterns that existed before and will exist after. The story does not close, it loops. Listening to this rhythm means accepting that some lives are not structured around conclusions. They unfold in cycles that do not point forward or backward, but remain centered on the present moment, repeated across years. The sperm whale's world continues below the surface, whether it is observed or not, shaped by sound rather than sight, by depth rather than horizon. Each dive is both ordinary and complete, containing within it everything needed to repeat the process again. There is no final descent, no definitive ascent, only movement between states that remain available as long as the body allows. Above, the surface world changes quickly and remembers itself through records and stories. Below, continuity persists, without narration. The whale moves through darkness that does not need explaining, carrying forward a way of life that has never required an audience.